Review of Chapter 2 Total Chapter 2 Reviv. Review. Vocabulary 1. Explain the relationship between electrons, neutrons, and protons. 2. What is the difference between an element and a compound? 3. Distinguish the differences in composition between an acid and a base. 4. Identify the type of reaction that releases free energy. 5. How are the processes of oxidation and reduction related? Multiple choice 6. The nucleus of an atom is made up of A protons and neutrons, B protons and electrons, C elements and compounds, D negatively charged particles. 7. High-energy particles that circle the nucleus of an atom are A ions, B protons, C electrons, D neutrons. 8. The way in which elements bond to form compounds depends on the A structural formula of the compound, B dissociation of the ions in the compound, C number and arrangement of electrons in the atoms of the element, D model of the atom. 9. If an atom is made up of 6 protons, 7 neutrons, and 6 electrons, then its atomic number is A19B, 13C, 7D, 6. 10. Atoms in a solid A are fixed in space and show no movement, B are fixed in space but vibrate in place, C move rapidly through space, D repel each other. 11. The amount of energy required for a chemical reaction to begin is called A chemical energy, B mechanical energy, C electrical energy, D activation energy. 12. The process in which a chemical reactant loses an electron, becoming more positively charged, is called A oxidation, B reduction, C metabolism, D stabilization. 13. In a reduction reaction, an atom gains A and A proton, B neutron, C electron, D nucleus. 14. An aqueous solution that contains more hydroxide ions than hydronium ions is A and A acid, B base, C gas, D solid. 15. Acid formed from sulfur dioxide in the atmosphere is present in A rocks, B acid precipitation, C weak bases, D pure water. Short answer 16. Use the pH scale shown below to answer the following questions. A. What is the most acidic body fluid represented? B. What is the most alkaline body fluid represented? C. What body fluid is closest to being a neutral solution? D. Which body fluid is most extremely acidic or basic? That is, which body fluid deviates the most from neutral pH? 17. An oxygen atom has 6 electrons in its outermost energy level. Explain why 2 oxygen atoms must share 4 electrons when they form a covalent bond. 18. What is an ion? 19. How and are electrons distributed in a covalent bond? 20. Name the physical states that matter can exist in. 21. In a chemical equation, what does a 2-direction arrow mean? 22. Many reactions in the cell are exergonic. Why, then, do cells need a continuous supply of energy? 23. What happens when water dissociates? 24. What does the word alkaline mean? 25. What does a buffer do? Critical thinking 1. Hydrogen gas exists as H2 rather than H. Why is this so? 2. How can a substance be changed from a solid to a liquid? From a liquid to a gas? 3. A magnesium atom has 2 electrons in its outermost energy level. A sulfur atom has 6 electrons in its outermost level. How will the 2 atoms react to form a bond? Explain why this is considered a redox reaction. 4. A decameter located on a fast-flowing mountain stream generates electricity. What kind of energy is transformed to create electricity? 5. The table shows melting and boiling points at normal pressure for 5 different elements or compounds. Above the boiling point, a compound or element exists as a gas. Below the freezing point, a compound or element exists as a solid. Use the table to answer the following questions. A. Under normal temperature and pressure conditions, which substances exist as solids? As liquids? As gases? B. Which substance exists as a liquid over the broadest range of temperature? C. Which substance exists as a liquid over the narrowest range of temperature? D. Which one of the substances are you least likely to encounter as a gas? Melting and boiling points at normal pressure. Substance melting point, boiling point. Aluminum 658 2330, argon -190-186, chlorine -104-34, mercury -39 357, water 0-100. Extension. Read the femtosecond camera shutter in Scientific American, January 2000, on page 15, and answer the following questions. What is the main obstacle scientists encounter in observing chemical reactions step by step? What was the key process Dr. Zewale used to observe chemical reactions? What was the chemical reaction observed using this new technique? What goals may ultimately be achieved using this technique? 2. Dissolve table salt or sugar by stirring it into water at room temperature until it is saturated. The solution is saturated when excess salt or sugar stays at the bottom of the container. Remove the clear solution at the top with a spoon, and place the remaining saturated solution in the refrigerator. After 2 hours, observe the cooled solution. What do your observations tell you about the effect of temperature on molecules in solution? Interactive exploration exploring the activity of biological catalysts. Simulate the effect of pH, temperature, and enzyme concentration on the activity of 2 enzymes. Determine the optimal conditions for each enzyme. 1ATR3ALS allows you to explore how 3 of these factors, enzyme concentration, temperature, and pH, affect the activity of 2 enzymes present in the human body, carbonic anhydrase and lysozyme. Carbonic anhydrase helps regulate carbon dioxide levels in red blood cells. Lysozyme breaks large sugar molecules into smaller ones during metabolism. Computer with CD-ROM DNV. CD-ROM interactive explorations in biology, cell biology and genetics. Graph paper background. All organisms rely on enzymes to catalyze chemical reactions. Recall that an enzyme is a biological catalyst that increases the rate of a chemical reaction by lowering the level of activation energy necessary to start the reaction. Without enzymes, many of the chemical reactions that occur within living things would proceed too slowly to be useful. Enzymes speed up these reactions by bringing the reactants into close proximity and facilitating their interaction. Enzyme effectiveness depends on several factors. This interactive investigation feedback meters pre-lab preparation 1. Load and start the program thermodynamics. You will see an animated diagram like the one below. Click the navigation button, and then click the topic information button with the key icon on it. Read the focus questions, and review the following concepts. Reaction rate, enzyme catalysis, temperature and reaction rates, and pH can influence enzyme shape. 2. Click the word help at the top left of the screen, and select how to use this exploration. Listen to the instructions for conducting the exploration. Click the interactive exploration button on the navigation palette to begin the exploration. Reaction rate displays reaction rate as a percentage of the maximal reaction variables. Relative enzyme concentration, vanes the concentration of the enzyme. Temperature, vanes the temperature. pH, varies the pH. Procedure part. A carbonic anhydrase activity 1. Click the new enzyme button until carbonic anhydrase appears at the top of the screen. 2. Click and drag the indicator so that the relative enzyme concentration is 0.2. 3. Click the plot point button. The point that appears on the graph indicates the rate of action for this enzyme concentration, expressed as a percentage of VMAX, the highest possible reaction rate. What is the T-action rate indicated by the reaction rate meter? 4. Repeat steps 2 and 3 until you have tested the following relative enzyme concentrations: 0.4, 0.6, 0.8, and 1.0. 5. Click the plot graph button. How does increasing the enzyme concentration affect the rate of reaction? 6. Make a table similar to table as shown below. Table of effects of temperature on reaction rate. Temperature, carbonic anhydrase, percent of VMAX, lysozyme, percent of VMAX, 0, 10, 20, C30, 40, C50. C7. Click and drag the indicator so that the temperature meter indicates 0. Click the plot point button and observe the result. In your table, record the reaction rate. 8. Repeat step 7 until you have tested the effects of the following temperatures: 10, 20, 30 C, 40 ccs, and 50. 9. Use graph paper to make a graph of temperature versus reaction rate. Draw a curve that connects your 6 points. What can you conclude about the effect of temperature on the activity of carbonic anhydrase? 10. Click the plot graph button. Compare your graph with the one shown on the screen. Explain any differences. Table B affects OF, pHO, and reaction rate. 11. Make a table similar to table B shown above. 12. Click and drag the indicator so that the pH meter indicates a pH of 3. Click the plot point button and observe the result. In your table, record the reaction rate. 13. Repeat step 12 until you have tested the following pH values: 4, 5, 6, 7, and 8. 14. After testing all the values above, make a graph of pH versus reaction rate. Draw a curve that connects your points. What can you conclude about the effect of pH on the activity of carbonic anhydrase? 15. Click the plot graph button. Compare your graph with the graph on the screen. Explain any differences. Part B, lysozyme activity 16. Click the new enzyme button until lysozyme appears at the top of the screen. 17. Repeat steps 2-15 for the enzyme lysozyme, completing table A and table B analysis and conclusions. 1. What is the optimal temperature for each enzyme? What is the optimal pH for each enzyme? 2. The optimal pH of pepsin, a stomach enzyme, is about 2, while the optimal pH of trypsin, an enzyme of the small intestine, is about 8. What must occur in your digestive tract between the stomach and the small intestine?